Hello Internet, my name is George and I'm the runner of GeorgeTutors. Today I'd like to take the opportunity to dive into my teaching philosophy that has been consistently bringing very good results for all the students that have been faithful to my tutoring programs. So let's dive right on in. A typical tutoring company just hands you or your kid a worksheet and basically answers questions when the kid or yourself gets stuck along the way. That's pretty basic. A private tutor steps this up a little bit by solving the problem alongside you or your child. A really good tutor, on the other hand, strategically places questions along the way of the problem-solving process, and the questions themselves are aimed in order to bring the correct answers from the student on their own. At GeorgeTutors, on the other hand, on top of everything I mentioned earlier, we use those strategically placed questions to identify every single one of those weaknesses that the student possesses, aimed to form a basis from which we derive an entire lesson plan that is directly targeting to eliminate those weaknesses. Alright, so for my high schoolers and their parents, let's pretend that student A showed up today and they were flabbergasted about sine and cosine and trigonometry. And they were like, oh my God, where do I get to see this in real life? So I was like, okay, let me sit you down and show you two very diverse applications so you can appreciate the subject matter more. The first one I decided to show them was projectile motion in physics, where they got to decompose a velocity vector into x and y components and therefore track the motion of an object in flight near the surface of the Earth. The second one was completely different. It was basically modeling an ocean tide basically over the course of a 24-hour period, where we spoon-fed them the amount of water change that the tide again demonstrates and the amount of time that it does so in. And then we asked them if they could put together a sinusoidal model that reflects the behavior of the ocean tide in that time frame. After these two examples, the student again showed much greater appreciation and understanding for the subject matter they had just been taught. Alright, so for my university chads out there, let's pretend that student B walks in, who's now taking a very complicated differential equation in their 2B term in university. Scary term comes around, 4-year series. They panic. I just take a step back and I go, do you remember back from when you took linear algebra, how you used to define a dot product and how the dot product gave properties to your bases whose again in between dot products were 0 and 1s? If you recall all of these things, we can then construct a bridge to the new concept now, which is a basis in a function space instead of a vector space. So you ask the question to the student, what is the equivalent operation that you can use in calculus for a function projection? Integral comes immediately into mind. So this is how you project a function on top of another one, equivalent to the dot product. And then you go, okay, how do we make bases functions from that? Well, you gotta take the inner product of the basis functions, then they have to obey the same stuff that your old vector bases did. That is, that their dot products, inner products called now, are giving you 0 when these indices are not the same, and 1 when they are. If that's satisfied, you're good to go. And then you realize Fourier series is nothing more than a function being projected into a bunch of other cosines and sines for the purposes of signal analysis, usually in ECE. And with that, the fear of Fourier series evaporates. So instead of spoon feeding you the actual answers, isn't it better to make you spiral around and then you yourself derive the correct answer? You feel more confident and you have a better understanding of what's going on around you. You can take those skills then and extrapolate them in later aspects of your life, wherever life may lead you. So the real question is, are you ready to start your own process of discovery? If so, you know what to do.